Let's talk about multiplication for a little bit. So when we're multiplying whole numbers, sometimes we might think of groups. So like 3 times 4, we could think of 3 groups of 4. Because check that out, that's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Because 3 times 4 is 12. I have 4 in each group, and I have 1, 2, 3 groups. Or if we're going to make an array to show multiplication, we can think of 3 rows of 4. I've got 1, 2, 3, 4 in each row, and then 1, 2, 3 rows. And I still have 12 dots there because 3 times 4 is 12. Now when we're thinking of multiplying with fractions, we see 1/3 times 6. And so what you need to think of is, well, that's asking you is what is 1/3 of 6? So if I've got my 6 dots, 1, 2, 3, 4, 5, 6, and I divide them into thirds, well, how much is each third? 2. 2 is 1/3 of 6. So 1/3 times 6 equals 2. And when you're multiplying fractions, then I have to think of what is 1/4 of 1/2. If I had a pie divided into halves, well, what would 1/4 of that half be divided into 4 pieces? Well, 1/4 of my half would be 1/8 of the whole pie. So 1/4 times 1/2 is 1/8. So here's 6 counters set up in an array. So go ahead and we're going to draw 2 lines to divide it into 3 equal parts. We're dividing it into thirds. Equal. 3 parts, 1, 2, 3, and they're equal because they each have the same number of counters. So to write a division sentence for what we just did, 6 divided by 3. Now we can rewrite this as a fraction. 6 times 1/3. So 6 times 1/3 is the same as 6 divided by 3. So let's write it in words. 6 times 1/3. So if I want to show 1/3 of this set, how many counters could I shade? Well, we'll shade in the thirds since we have it divided into 3 parts. Okay, and that's 2. So 1/3 of 6 is equal to 2. How many counters should I shade to show 2/3? Well, if I was doing 2/3, I'd have to shade in this third and this third for a total of 4. So what is 2/3 of 6? 4. 2/3 of 6 equals 4. So 3/3 is a whole, which you guys know that. You know that 3/3 would be 1, and the whole set is 6. So 3/3 of 6 would be 6. So we can count. 2 counters is 1/3, 4 counters is 2/3, 6 counters is 3/3. So following this pattern, what would 4/3 be? Well, 2, 4, 6, 8. 4/3 of 6 would be 8. And since 4/3 is an improper fraction, that's why it's bigger than 6. Because 4/3 is bigger than a whole. All right, now instead of 6, we're going to look at fractions of 12. So here we're taking a look at 1/4 of 12. If I divide 12 into 4 equal pieces, what is 1/4? So let's go, let's see. Yep, that's 1, 2, 3, 4 equal pieces. Well, how many are in each? 1, 2, 3. So 1/4 of 12 equals 3. So how many counters are in each fourth? That's again a 3. So write the division sentence as a fraction. So instead of 12 divided by 4, we're going to say 12 times 1/4. So what is 1/4 of 12? Once again, 3. Now look at your array. What fraction of 12 is equal to 6 counters? So here's 6. So what fraction is that? Well, there's 6 here, there's 6 here, so there's 2 groups of 6. So what fraction has a 2 in the denominator? Half. Or 2/4. So another way to say 2/4 is half. So see, we could think of it as halves, 1/2, 2/2, or fourths, 2/4, 3 4/4, but half is the reduced fraction, so that's what we're going to use. So, is 1/2 of 12 equal to 6? Yes. So Mrs. Pham has 8 apples. She wants to give 3/4 of the apples to her students. How many apples will her students get? Alright, so I've got my 8 apples drawn there. And let's see, what are we dealing in? Fourths. So let's make fourths. So fourths means there's 4 sections, and they're all of equal size. And it says 3/4. So I'm going to color in this fourth. I'm going to color in a second fourth. And there, I've colored in 3 of my fourths. So how many apples is that? Well, that's 1, 2, 3, 4, 5, 6. 6 apples. So 3/4 of 8 equals 6. Go ahead and write your answer to the word problem in a sentence, and then raise your hand for me to come take a look. So in a class of 24 students, 5/6 are boys. How many boys are in the class? So let's see, let's divide them into sixths. So there, I've got them divided into 6, and now we're going to color in 5. So I colored in 5 of my 6. I colored in this one, this one, this one, this one, and this one. This one I left blank though, because it only says 5/6. So how many students are in the whole class? 24. We know that because it said right there. So what is the question in this problem? Well, to write it as a math question, I would say 24 times 5/6. So what fraction of the whole class of 24 are boys? What fraction of this class is boys? Well, it tells us right there, 5/6. So will our answer be more than half the class or less than half? Well, check it out. We had to color in way more than half. So way more. So what's 1/6 of 24? Well, I colored in 5/6 here, and there's 1/6 left over. So 1, 2, 3, 4. So 1/6 of 24 is 4. And with a division sentence, we would say 24 divided by 6. So how can you use 1/6 of 24 to help solve for 5/6? Well, this, you know, is 5 times bigger than this. So 5/6 is 5 times bigger than 1/6. So if I figure out 1/6, then, and I know it's 4, then I just have to go, oh, well, 4 times 5 is 20. If we count all these guys, that's 20. So we know that 1/6 times 5 would equal 5/6. And that's what that problem was asking for. So if we wanted to use a bar diagram, we could go like this. We're going to divide this into sixths, because this problem is dealing in sixths. And then how many? Oh, 5. We want to color in 5 of them. So we know this whole thing is 24. But what we want to know is how many is just the 5/6. So if the whole thing's 24, then we know that each chunk is worth 4 students. So then to figure out how many the 5/6 is, we just need to count by 4s. 4, 8, 12, 16, 20. So if 6 units are 24, how many circles are in 1 unit? Well, we drew them. So what division sentence shows this? 1/6 of 24, or 24 divided by 6? Which is 4. So 5 units worth, 4 times 5 is 20. On your own, please go ahead and write this in a word sentence. So when you're working on your problem set, 5th graders, you can use a tape diagram or a bar diagram like this, or you can draw the counters like we did earlier in the notes. Totally up to you. I will accept either one. All right, on to the problem set. Good luck.